All right, guys, so today we are going to work on solving radical equations with rational exponents. I don't have an extra copy of the packet today, so I am going to be doing this on a piece of paper because I'm going to try to do it live with the class tomorrow. But I do have everything written down here, so I just wanted to show this to you so you can see it. And we're going to go through here and go through these notes. Now, the very first thing here, when we're solving radical equations that have exponents here, so you're going to see some exponents that are fractions, that's what that means. What you want to do is get the variable or maybe an expression that's to an exponent by itself on one side of the equation, and then to solve it, okay, what we're going to do is the process that's written right under here, but I'm going to leave that so you guys can kind of see it. But in that little blank spot, before we get to the n is even, n is odd, all that, this is the equation you're solving. The power you are going to raise both sides to is going to be the reciprocal of that exponent in the original equation. So m over n is what I'm looking for in that little blank right there. And I'm just going to kind of show this on the screen and then we'll go over a couple examples. So x to the n over m equals k. You raise both sides to the reciprocal power. The reason for that is because power to a power, you're going to multiply the exponents. And when you multiply a fraction by its reciprocal, it becomes 1, essentially canceling it out. Okay, so once you do that on that side of the equation, what you're left with is the other side of the equation to that power. So I'm just going to give you a couple examples. There's two different things you have to work with depending on if the top of the fraction, the numerator, is even or odd. And I'm going to go through and explain those two little blanks here with an example. Okay, so here's what you guys had, and then I got example 1 underneath there. So we'll get that going here in a second. Okay, so if n is even, the numerator is what I'm talking about there. I've got the expression isolated in both of these tiny little examples. Okay, so here's the deal. This is x to the 2/3 power equals 36. What I want to do to cancel out that exponent is raise both sides to the reciprocal power. Okay, now, what I'm doing here then, if I multiply 2/3 by 3 over 2, it becomes 1, and what we're going to be left with then here is just a plain x. Now, on the other side of the equation, anytime my numerator is even, like it was here, if I translate this into radical form real quick, I'm going to do that bottom out thing, this would become the square root of 36, and then that would be cubed. Okay, now what I have to remember here, if I do a square root or a fourth root or a sixth root, all of those being even numbers, I've introduced the root into the problem, and I have to remember that plus and minus symbol because there's actually going to be two answers here to this question. So anytime the numerator is even, that means that when I take both sides to the reciprocal power, I am going to be taking a square root or a fourth root or something like that. And so that gives me that plus and minus symbol that would have two answers. Now, hopefully you guys are comfortable doing this. Square root of 36 would be 6, and then to the third power, that would be 216. So positive 216 or negative 216, both of those will work as answers there. So only if the numerator is even. Okay, now if the numerator is odd, like it is here, what we're going to end up doing on the second question I have, my example, x to the 3 over 2 equals 27. Here I'm going to take both sides to the 2/3 power. Okay, over here on the left side, I'm just going to, again, end up with x. If I multiply those exponents, it would give me 1, so it would just leave me with x to the first, or x. Here, bottom out, now this is a cube root of 27, and then that would be squared. So if I'm taking a cube root or a fifth root, there's no need for a plus and minus. There's only one answer if you do an odd root. Even roots have the plus and minus, odd do not, so no plus and minus here. So I might make that note, no worries about plus and minus. This is just going to have one answer. And all I would do here to get that answer is the third root of 27 would be 3, and then we'd have to square that. So my answer there would just be 9. The previous question, if the numerator is odd, potential for 2 answers. Okay, so we're just going to do a couple examples. And here's your first example, and you guys have this written in the paper form, hopefully on your notes. I've got 3 times the quantity x plus 1 to the 3/5. Now, I didn't have this on the 2 examples I had at the top, but I want to isolate whatever's being taken to that exponent. So my first step here is to get rid of that 3. Do not ever distribute anything into parentheses that have an exponent. We want to divide to get rid of that. Okay, so I'm just going to write it over here so I have a little tiny bit more space. So x plus 1 to the 3/5 power is going to be equal to 8. Now, sorry, I should have looked at this before I started. My numerator is odd, so I don't have to worry about a plus and minus symbol, so we're not even going to think about that. I'm just going to continue on with the problem. So, like I was telling you, all you got to do is raise both sides to the reciprocal power. Okay, 3/5 times 5/3, that's 1, so that goes away. So we're just going to drop the parentheses over here. We'll get x plus 1. Now, this guy, and if you want to write that to the side, it's up to you. This is going to be, bottom out, the cube root of 8 to the 5th. Okay, now, cube root of 8 is just going to be 2. And then to the 5th power, that's going to be 32. All right, so here I've got x plus 1, and the cube root of 8 to the 5th is 32, and I just have one more step, and that's to subtract the 1. So my answer to that question would be 31. And you can, of course, plug that back in to check. All right, now a couple different examples here. This is at the bottom of your page. So here I've got, again, 1/2 x to the 4/3 minus 4 equals 124. First thing you want to do is isolate where you have the radical exponent, or rational exponent, excuse me. So I'm going to get this by itself. All right, now I've got this minus 4, so I'm just going to get rid of the 4 by adding that there. I'm going to get 1/2 x to the 4/3 power is equal to 128. All right, now the 1/2 is not being taken to that 4/3 power, so I'm still isolating that part of the expression. I want to divide by 1/2, or dividing by 1/2 is the same thing as multiplying by 2, so whichever you want to think about it. This is going to end up being x to the 4/3, and then 128 divided by 1/2 or multiplied by 2 is 256. Okay, now for this question, the numerator is even. So when I take both sides to the reciprocal power there, I'm going to end up taking a 4th root. Anytime you take an even root, you got to put a plus and minus symbol. So I'm going to keep that in mind when I'm doing this part of the problem. All right, so both sides, to the 3/4 power. 4/3 times 3/4, power to a power, multiply the exponents, those cancel out. So I'm just going to get an x here. Okay, now, if you want to do a little aside for this, I'm going to work this out. This is the 4th root of 256 to the 3rd power. If you guys look at your perfect fourths, and if you want to grab that little yellow paper, 256 is the 4th down, so the 4th root of 256 is 4. So this would then be 4 to the 3rd, which is going to be 64. Now, because this is a 4th root, I have to put plus and minus, so my 2 answers to this question could be 64 or could be negative 64. And of course, you guys can plug that back in to check. All right, just going to do this last example and then we'll flip to the back, and I'm going to slide this over a little bit so my face is not in the way. Okay, isolate whatever's being taken to your rational exponent. So I got to start this guy out by dividing by 4. We're going to have x plus 5 to the 2/3 power is equal to 9. Okay, now my numerator, again, is even here. So when I take both sides to the reciprocal power, that's going to cause us to take a square root. So don't forget, this is going to have two possible answers with your plus and minus. All right, so we're going to take both sides to the 3/2 power. 2/3 power to a power, multiply the exponents, times that 3/2 is just going to be x plus 5 to the first. So that's just going to cancel out. Now, over here, and if you want to do like a little aside, this bottom out is the square root of 9 to the third. So the square root of 9 is 3, and then when I take that to the third power, I'm going to get 27. So don't forget though, because we took a square root here, square root, I need a plus and minus. All right, so when I do this question, plus and minus 27. Now, this is a little different than the previous question because I have x plus 5 equals this. So what I want to do is do x plus 5 could be positive 27, or x plus 5 could be negative 27. In both cases, you'd subtract 5, but you're going to get two totally different answers. Here, if I subtract 5 from 27, 22 is one of our answers. Here, if I subtract 5 from negative 27, we're going to get negative 32. And so those are going to be our two answers there. Oops, sorry, my little picture's in the way. 22 and negative 32. And of course, you can plug these right back into the original problem and you will see that they will make that equation true. All right, guys. Now, on the back here, different than the front. Each of the equations on the front was just equal to a number, so you don't have to worry about this. But on these two questions on the back, here in example 2, if you have variables on both sides of the equation, which we're going to have here, you've got to make sure you check for extraneous solutions. So if you guys look at this original problem, that 1/2 power, that is the same thing as taking a square root. So I cannot have whatever is over here end up being a negative because we're not going to be able to have that square root equal to a negative. So keep that in mind as you're going through here. We are going to have to check for extraneous solutions anytime our equation is equal to an expression instead of like the front where it's just a plain number. Everything else is going to kind of run the same, but these are going to be a little bit more complicated than the ones we were doing on the front. I've got already the expression with the rational exponent isolated. So I am going to take both sides just to square. All right, and then maybe just to start out here, my numerator in that problem was odd, and I'm not on the screen, forgive me. My numerator was odd, so I don't have to worry about the plus and minus symbol, because what we're going to do here is actually just square both sides, so I'm not taking an even root. All right, now what's going to happen here, this guy, 1/2 times 2, power to a power, multiply the exponents, that's just going to stay 1. And over here, don't distribute. I know someone did. Don't distribute. Remember, if you are squaring an expression, any adding or subtracting ruins our ability to distribute the exponent because we'll miss out on the middle term. So that's going to be a FOIL situation there. Okay, so if you want to draw yourself a box, feel free. This is going to be x squared plus x plus another x plus 1. 1 times 1 is 1. Simplify this, you're going to get x squared plus 2x plus 1, and I'm just going to bring down this 5 minus x. Okay, now we are going to end up with a quadratic here, so don't freak out. We do want to set this equal to 0, and I would really suggest keep your squared term positive. So to do that, I'm going to subtract 5 and add x, and I'll just line those up. So I'm going to add x to the 2x here, and I'm going to subtract 5 from the 1. So we would end up with 0, and then x squared plus 3x minus 4. Now, completely up to you. You can use the quadratic formula, or I'm going to give you questions that you can factor. So I'm going to factor because that's a little faster for me. I need two numbers that when I multiply them, I get -4, and when I add those same two numbers, I get 3. Only two numbers fit both of those requirements, and that's going to be, let's see, -1 and +4 there. So my factored form should be x minus 1 times x plus 4. If you multiply that back out, that'll give you what we have there. My two possible answers then are 1 and -4. You have to check that original problem up there, that 1/2 power is the same thing as the square root. So make sure that you plug these back in to check if this side of the equation ends up being negative. I can't take a square root and get a negative number, so you got to check that. So if I put 1 right back up here, that would give me a +2, good to go. That will be our answer. If I check the -4 though, if I do -4 plus 1, that'll give me -3. So this -4 is going to be an extraneous solution. So my only answer to that question is 1. We did all the algebra right, but it's that act of squaring that can cause you to have an extraneous solution. Okay. We're going to do one more. This is a little different. All right, and what I've got going on here, both of these have rational exponents. I can't really isolate anything further. I mean, they're both on their own side of the equation. And so what I need to do here, this is a little tricky. These exponents are different. So I would ask you, think of what you could do. Can't just use a reciprocal here. What could I do to cancel out both of those fractions at once? So if I use the reciprocal of the 1/2, what that would do is that would cancel out, I could do 2 both sides, but this would still be a fraction. We want to get rid of the fraction. So try to think of a number that both of these could get canceled out by, and I would tell you for this question, it would just be the lowest common denominator between the two of them, which would actually be 4 in this case. So what I want to do, I'm going to raise both sides to the 4th power. I'm going to try to cancel out both of those fractions with as small a number as possible in one step. Okay, power to a power here. If you do, oh, sorry, let me move that down a little bit. If I do 1/2 of 4, that's equal to 2. So it's not going to cancel out the exponent, but it is going to cancel out the exponent being a fraction. It will be an integer if I do that. So this would become 2x plus 1, but that's going to be squared. Okay, the other side, if I take that to the 4th power, those are reciprocals. That will just straight up cancel out. So this would become 3x plus 4. Now, what's going to happen here, we're going to have to multiply this out. And FOIL or box, it's completely up to you. I'm going to get 4x squared plus 2x plus another 2x plus 1. Totally simplified, we'd get 4x squared plus 4x. And then we're going to get plus 1. And then I'm just bringing down that 3x. Oh my goodness, sorry, my picture's in the way. Just bringing down that 3x plus 4. All right, so then when we get that all squared away, I'm going to set this equal to 0. So I'm going to subtract the 3x, subtract the 4. I just lined those up with the two terms over here. So we're going to get 4x squared plus x and then minus 3. Set that equal to 0. Now, totally up to you. You can use factoring to factor this, or you can use the quadratic formula, whatever your preference is here. Maybe what I'll go ahead and use the quadratic formula since we used factoring on the last one. So my a is 4, my b is 1, my c is -3. So if you don't remember quadratic formula, you can always use that to solve a quadratic equation. Opposite of b plus or minus, square root b squared minus 4ac all over 2a. So if you like that, go ahead and use that. I'll use that on this example. So I'm going to have -1 plus or minus the square root 1 squared minus 4 times 4 times -3. Everybody over 2 times a, which is 2 times 4 here. All right, guys, I'm having a little trouble with the lighting. Hopefully this isn't too dark. All right, so I got -1 plus or minus square root. All right, 1 squared 4 times -3. This is going to end up being a minus a negative. 4 times 4 is 16 times -3 is -48. minus a negative, I'm going to have 1, which is 1 squared, minus a negative 48. That's actually going to give you a 49. On the bottom, I get 8. Now, if you ever get a perfect square under the square root in your quadratic formula, what that just means is that that was factorable. So if you wanted to factor instead, you definitely could. All right, so I get negative 1 plus or minus 7 over 8. So if I do negative 1 plus 7, divide by 8, I get 6 over 8, which is 3/4. So there's your one option. The other option, negative 1 minus 7 over 8, which would be negative 8 over 8, which is just negative 1. So those are our two options. And I'm on that little picture again, my apologies. Okay, now here's what we got to do. We got to check because we have these expressions. So I just kind of cut the original problem so we could see this at the same time. So these are the two answers I got to check, the 3/4 and the negative 1. If you guys remember, this is a square root and a 4th root, and I cannot do either one of those for a negative number. So if you plug in, if I do 2 times 3/4 plus 1, that's what I would have to the 1/2 power. As long as that's positive, you should be okay. I'm getting 2/5 there. And then I'm also going to check real quick the, make sure I don't take the 4th root of a negative number. So 3 times that 3/4 plus 4. Whoa, sorry, not tangent. And I know the numbers are different, but as long as they're both positive, you're golden. Now, the other number we got to plug in is the negative 1. So if I do 2 times negative 1, and I add 1 to that, there we're trying to take the square root of a negative. So immediately I know that I'm going to have an extra answer. This negative 1 is not going to work, and the 3/4 should be our only answer there. All right, guys, and one last question here. What we've got going on in this is actually a radical equation, so just one more here. The tricky part to this question, we want to isolate a radical or a rational exponents expression anytime we're doing these problems. Here the issue is I have isolated these radicals as much as possible, and I have this minus 1 on the outside. So what we're going to do here, we're going to square to cancel out the 4th root, or sorry, the square root. I don't know, I just said that. The issue is here, how do I FOIL this? So on this side, you're just going to get x minus 9. Again, don't distribute anytime you have adding or subtracting. What we're going to do is a FOIL here. So just to practice, how would this look? All right, square root of x times the square root of x would be the square root of x squared. All right, square root of x times negative 1 would be just a negative 1, and if you want to write that, you can. You don't have to. I'm just going to write it in this problem as I go. Negative 1 times the square root of x again. These are actually going to be like radicals that we will combine. Negative 1 times negative 1 is 1. Okay, this is a perfect square. The square root of x squared would be simplified to be an x. Now I have minus 2 of these square roots of x, and then plus 1. And I'm just going to bring down what we had here, the x minus 9, from the original beginning of the problem after I squared both sides. Now, this looks kind of complicated, but actually what's going to happen, if I try to combine like terms, if I subtract x there to get those on the same side of the equation, cancels out on both sides. So I get here negative 9, negative 2 times the square root of x plus 1. So I'm just going to try to isolate this radical. So get rid of the negative 1 by subtracting this. Negative 10 is equal to negative 2 times the square root of x. Get rid of the negative 2. I'm multiplying, so I'm going to divide to cancel that out. And then we're going to end up with 5 equals the square root of x. Now, to cancel out a square root, all we have to do to both sides is square that. And so I'm going to end up with my plain x equal to 25. And if you plug that back in the original problem, it works in both cases. So it's not an extraneous solution, it will work.